Good morning, guys. How you doing? Okay? Okay, so you'll have some good news today. Okay? The good news is we're not doing anything new. So there's nothing new to learn. All it is, we're just doing examples from the last two lessons that we did, which are talking about direct proportion and inverse proportion. Okay, so we're on page 239. Well, the other thing is, you might notice I've changed my location slightly, so I'm hoping that the board is easy and things will be easy to see. Okay, so on page 239, okay, so first of all, there's a quick summary about the differences between direct proportions and inverse proportions, okay? Okay, so I've put the table on the board, pause the video while we do that, but anyway. So here we have a set of figures that are in direct proportion to each other. How do we know that they're in direct proportion? Okay, well, the easiest thing to do, and I say you can do this in different ways. Okay, there's two different ways of doing it. There's the way that the book talks about, and I'll mention this a bit more later. But there's my way of doing it, which I think is just straightforward. But anyway, we can look at the numbers here. Okay, so we've got 3. What do you do to 3 to get 6? You multiply it by 2. What do you do to 24 to get 48? You multiply by 2. Okay. There's other ones here. We could do the same one here. We could do what do you do to 3 to get 15? You times it by 5. What do you do to 24? You do the same thing at the top. You do to the bottom with direct proportion. So you times that by 5 to get 120. Okay. So that's one way of seeing whether something is in direct proportion straight away, just to see if the multiplication is the same at the top as it is at the bottom. Okay? Straightforward. Alright, the second thing is we talked about algebraic expressions, and we said that direct proportions we can always write as x equals ky. Now in the book it says m, but most places, when they're talking about direct proportion or inverse proportion, they seem to use the word k. I don't know why, but anyway, there we go. The book says m, so put m in if you want to, but whatever. Okay, so x equals ky. We can look at these ones, and we can say, what have I done there? I've done those from way around. Why did I do that? X and y, okay? And these should be the way around as well. Sorry. Y equals k times x, okay? So we've got here 24, we can work out the equation by saying 24 equals k times by 3. We divide the 3 here to get rid of it on this side. We divide here, so k equals 8, okay? So our equation here for this direct proportion is y equals 8 times x. And we can check it with the other ones here, where y equals 8 times x, so we can say y 48 equals 8 times 6. So we've got that right, and we can check the direct proportion, see whether it is in direct proportion by doing that, and we'll do more of that later. Okay, and the other two things, if we put these on a graph, again this isn't in the book, if we put these on a graph, if they're in direct proportion, there are two things, okay? One, it's in a straight line. Okay? The first thing is, if we put them onto a graph, put the points onto the graph, join them together, we have a straight line. And the second one is that it passes through the origin. The origin, and we know is 0, 0 on the graph. Okay? So that's it really. Figures, if you have some information, the question asks you, is it in direct proportion? Okay, first of all, look to see if it times by the same numbers. Okay? Then Work out your formula. If the formula works for two different sets of information, then it's in direct proportion. The second thing, if you put it onto a graph, then if it's a straight line and it passes through the origin, then it's in direct proportion. Okay? Straightforward. That's direct proportions, okay? Hang on a minute, I'll just pause. And as if by magic, the board will disappear and something else will appear. Okay, so moving on to inverse proportion. Did you like the way the board changed just like that? Amazing, modern technology. Okay, so, yes, I know, I just paused the video. Alright, okay. Alright, so here we have some data, some information that's in inverse proportion to each other. Now, okay, so how do we know it's in inverse proportion? Okay, so as far as I can think, there's two ways to do this, okay? The easiest way is to look at the information. Okay, inverse proportion, the x value in this case, one set of information goes up, and then the other set of information goes down. Direct proportion, they both go up at the same time, x and y. Inverse proportion, one goes up, the other one goes down. That's it, as far as I can see anyway. That's the easiest way. The second way to do it is to work out the equation, okay, which we're going to do in a minute, right? So, no, it's not corona. Okay, so here, if we had the direct proportion, remember we said that y equals k times x, okay? For inverse proportion, it's the opposite. It's not the opposite, but it's k over x. Okay? So, we're looking at this then. So, let's work out our formula for this, if you like. Work out how we would show that this is inverse proportion. Let's do it both ways, actually. Let's stop a minute. Let's do it both ways. Okay. So, let's work out, is it directed proportion first? Because these are some of the questions that you get asked later on in the exercises. So, is it direct proportion? Well, direct proportion is y equals k times x. Okay? So, let's put the numbers in and work out what k is, if this is true. Okay? 24 equals k times 3. Okay, that sounds right. There. K equals 8. Alright? So, y equals 8 times x. That would be nice, wouldn't it? Alright? So let's try it. Try with this one here, okay? So we put the numbers in. 12 equals k times x, 8 times 6. 8 times 6 does not equal 12. 8 times 6 equals 48. So y does not equal k times x, so this cannot be inversely direct proportional. Okay? So that's one way, that's the second way. Remember I showed you the first way before was just by multiplying it out. The second way to see if it's direct proportion is seeing if the equation works. Okay? Here, the equation doesn't work, so this is not direct proportion. Okay? So, let's do the other one. Is it inverse proportion? Is it inversely proportional? Well, what's the equation for the inverse proportion? Equation for the inverse proportion is y equals k over x. Now, again, I don't quite understand why it does it like this, but the book says x by y equals k. Now, I don't know why they decided to write it like that, but to me this is an easy way to write the equation, because then you can work out what the value of y is. If you have x times y equals k, then you still have to divide it out later on anyway, so why not just come up with the equation in the first place? Anyway, I don't know, so I'm going to write it like this. I say the book writes it like xy equals k, but you can choose to do what you want, okay? But this is the way I'm going to do it. Okay, so you've got y equals k over x, so again, let's put the figures in. Y, 24 equals k over 3, okay? Yeah, so k equals 24 times 3. For those of you who can do maths and everything like that in your head, actually I just did this one on my head. I knew the answer, but I just did it in my head as well. 2 times 3 is 6, plus 4 times 3 is 32. equals 72. So our formula for this one, if it is inversely proportional, is y equals 72 divided by x. Okay? So let's check it. We know that this one works. Let's try a different one. I don't know, do the 12 one again. It's easier, yes? Okay? Yeah? So 12 equals 72 divided by 6. Yeah, that's true. So therefore we know this is inversely proportional. Okay? The other thing with inversely proportional, if you put it on a graph, you can see examples in the book. I'm not going to do it here. I don't know where this one lies actually. But a graph, normally it's something like that. Okay? On a graph. It's not a straight line and it doesn't pass through the origin. Okay? Any other things there? No, I think that's straightforward, really. Okay, so again, in the book you have two examples of how to go through and how to work these things out. So what I'm going to do is carry on to page 240, which are the examples that you're supposed to be working out. If I do a couple of those, and then we'll carry on and you can carry on and do the rest. Yes, alright? Is that okay? Hope so. Yeah, good. Right, okay, let me stop this again, save you sitting while I wipe the board. Okay, if my magic, the board is clean, and we've now got a new number, page 240 at the top. Okay, so, right, remember, keep in your mind the two equations for the direct proportions, okay? So the first one is direct proportion, y equals k times x, inverse. Why don't they call it direct and indirect? I don't know anyway. Y equals k over x. Okay? So keep in mind those equations, because those are the equations that you need to use in order to find out what's going on, basically. Right, okay, so when you look at question number 1 here, okay? And again, there's a clue here. I'll read the question. George is walking at a constant speed. In 5 minutes he walks 400 meters. Now to me, when I look at that, the first thing that says to me that it's direct proportion is the fact that he's walking at a constant speed. If the speed remains the same, then it's going to be direct proportion. If the speed changes, then it would be inverse proportion. But in this case, we've got the speed remaining the same, so therefore it's going to be direct proportion. Okay, so we've got here, first question. So we'll do question 1. A. Should we change colour? I'm not sure. Tell me which colour is the best. The red or the black? Yeah, red or black. We'll do the rest in black, okay. So, the first one, okay? Let's just do some examples. It says, is the distance travelled proportional to the time taken in minutes? Okay? Right, okay? Well, I've just given you one explanation as to why that's right, why I think that's right anyway. The other way we can do it is to work out some of the numbers and see how it works, okay? So for example here, we could have 5 minutes. He travels 400 meters. Okay? And then in 10 minutes, he would travel 800 meters. Okay? And again, you can see by looking at the information there, 5 times by 2 is 10, 4 times by 2 is 8, or 400 times by 2 is 800. Okay? Now, it asks us to write down a formula for D in terms of T. So we look at our equation here, direct proportion, y equals k times x. So we've got 400 equals k times 5. Okay? So, k equals, we do this, divide it out. Okay, so we've got here that k is equal to 80. Alright? So our formula for this would be y, or in this case, what we're working out here, we're talking about the distance and time. Okay? So we've got the distance equals 80 times the time. I guess we could write that as D equals 80t. Okay? And the last one there, it says, use the formula to work out how far George walks in 8.5 minutes. So we've got the time here is 8.5, yeah? So D, the distance, equals 80 times 8.5, okay? 8 8 is 64, 640 plus half of it would be 680, yes? 680 meters. Okay? Straightforward, yes, really? Leave that there for a minute. If you have any problems with that, please let me know. Okay? Blah, 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 blah. Let's go down to one of these other ones. Question 3. Question 3 is a bit of an interesting one. Okay? I'll take that off the board and then we'll come back to question 3. Okay, so this is question 3, part A here. Okay? We've got our x and the y's here type thing. Okay, so it's asking us to find out if they are directly proportional, inversely proportional, or neither. Okay, now, again, this is the way I would do this, okay? If there's other ways to do it, please tell me, but this is the way I would do this, okay? We know our formulas are here, okay? If it's direct proportion, this formula, the formula we work out for this, should be the same as the formula that applies to this. If it's inversely proportional, then again, same thing. This formula should work here, but it should also work here. Alright? So that's the way I did this, okay? I say, if there's another way to do it, then you can tell me, okay? But this is the way that I did it, okay? Straightforward, really. So, let's try and see if it's directly proportional first, okay? So, if it's directly proportional, y equals kx. So, in this case, 36 would be k times 12, so therefore k equals 3. Okay, straightforward, that would be nice, wouldn't it? Again, it's a nice number. So let's try it, okay? Let's try with this one here. 20. Say it's still not common, don't we? Okay, 20 equals 3 times 5? No. 20 doesn't equal 3 times 5. So, there it's not. So it's not directly proportional. Okay? So, let's do it the other way. Inverse proportional. If it's inverse proportional, then this formula should work. Y equals k over x. Again, working through, in this case, we'll do the same one, it doesn't matter. 36 equals k over 12. Oh goodness me, I shouldn't have done that one, should I? So what does k equal in this case? Where's my proof sheet here? Okay. Okay, yes. 20. Okay, I did it with a different number here, it doesn't matter. Okay, so we got here that k should equal 12 times 36. What's 12 times 36, somebody? Okay, so let's work this out. 36 times 12. Okay, 6 12s are 72. 2 down carry 7. 3 12s are 36. Plus 7 is 44, yes? 40. 36 plus 7 is 43. Okay? 0 down there, 1 6 is 6. Oh, sorry, 1's. That's it, 432. What are we on about? So that's it. I did it, yes? 432. So k would equal 432. Okay? Yeah? So let's try with one of the other ones. Okay? So the equation here would be y equals 432 divided by x. Okay, so let's try with one of the ones, and you can see straight away it's not going to work. Okay? So we got here 20 equals 432 divided by 5. No, it doesn't. So this one is neither. It's not directly proportional and it's not inversely proportional. So our answer to question 3, this is 3a. The answer to 3a would be neither. It's not directly proportional and it's not inversely proportional. Okay, so we'll just do one more, again, magic here on whiteboard, and then we'll start again with question B, and then you can do questions C and D. Okay, so let's do this one quickly. I'm aware that I've gone on for 20 minutes so far. Anyway, let's try and do this quickly. Okay, so direct, if it's direct proportional, again, same thing, y equals kx. Work one of them out. Which ones did I do here? I've got the numbers down in front of me. 3 equals k times 30. So therefore, k would equal to 1/10. Okay? So the formula would be y equals 0.1 of x. Okay? So let's try it with one of the other ones. 60 equals 0.1 of 1.5. No, it doesn't equal that. So we know it's not directly proportional, so it's not directly proportional. Okay? Let me just put that down there. And I can take that off and I'll do the next one over here. Okay? So is it inversely proportional? The formula we got here is y equals k over x. Again, look at the crib sheet here. 3 equals k over 20. Yeah? 30, sorry. Yeah? So therefore, k equals 90. Alright? So our formula would be y equals 90 over x. Okay? So let's try one of the other ones to see whether it's right again. Again, we can use the 60 one. 60 equals 90 over 1.5. Yes, it does equal. So therefore, this one is inversely proportional. Okay, so I hope that's clear. I say I want to stop now because I've just done 21 minutes and I hope I'm not going to have problems with YouTube again. I did this last time and I had problems. Anyway, okay. I hope that makes clear. Carry on and see if you can try some of the other exercises. Alright, thank you very much.